welcome you all to our brilliant channel Maths Nation. Dear students, if you have not subscribed Maths Nation, kindly subscribe it now, and I promise to complete your syllabus and would like to solve your all queries which you may kindly drop in my comment box. So dear students, in my last session, this is revisionary series. In my last sessions we have discussed about chapter 2. In this session we will discuss about chapter 3. The video will contain the whole chapter 3. Today we discuss the chapter 3, rational numbers as decimals. You know what is rational number? The numbers which can be expressed in p by q form is called rational number. The number which can be expressed in p by q form where q is not equal to 0 is the rational number. Suppose 3 by 4. 3 by 4 is a rational number. And here 4 by 5 is also a rational number. Here we have to convert the rational numbers to decimal numbers. How can we convert the decimal numbers into decimal numbers? The rational numbers can be converted into the decimal numbers by converting the denominator into either into 10 or power of 10s. Suppose this is 3 upon 4, this is 4 upon 5, suppose this is 4 upon 10. Then this can be converted into decimal forms. 4 upon 10 is 0.4. But those suppose 3 upon 125. Then here the denominator is 125. At first we try to convert the denominator into either 10 or 10 ki power. Suppose this is 3 upon 4. 3 upon 4. Then here the denominator is 4. Convert this into 10 or power of 10 by multiplying it with 25. When we multiply with 25, we have to multiply both in numerator and denominator. Otherwise the value will be changed. Now this is 3 upon 4. This is 75 upon 100. 75 upon 100 can be converted into decimals. Here how many numbers after here the denominator has how many 0? 2 0. Then we require 2 numbers after decimal. This is 75. Then this is written as 0.75. Suppose this is 5 upon 20. Then here the denominator is 20. To convert it into 10 or power of 10, we multiply this with 5. Then when we multiply 5, we must multiply the numerator and denominator both with 5. Then this is, otherwise the value will be changed. This is 25 upon 100. 25 upon 100. Here how many zeros are in denominator? This is 2 0. Then we require 2 numbers after decimal. This can be written as 0.25. Suppose this is 7 upon 4. Then here the denominator is 4. Then we have to convert the 4 into the 10 or power of 10. 4 cannot be converted into 10 because 4 is not a factor of 10. Then 4 can be converted into 25 by multiplying with 25. 4 can be converted into 100 by multiplying 25 because 4 is the factor of 100. 4 is not the factor of 10. Then when we multiply 25, we must multiply the numerator and denominator both by 25. Then this is 175 upon 100. Then in 100 how many zeros are there? There are 2 zeros. Then we require 2 numbers after decimal. Then 175 upon 100 can be written as 1.75. This is the decimal form of 7 upon 4. These are all terminating rational numbers. Then we can convert it into decimal numbers. Here look at here. Suppose they are express the following rational number as decimals. Do some examples. Express the following rational numbers into decimal form. Suppose here 9 upon 8. Here the 9 upon 8. Students, I have already told you, please practice your worksheet and ask me your doubt. I have promised to complete your syllabus. I have already completed my syllabus. Please go through my all previous videos. You can find the whole seven chapters are covered. Class 7 whole mathematics chapters are covered, and this is revisionary third video. In first video I have discussed about chapter 1, then in second video we discussed about chapter 2, and in the third video we discussed about chapter 3. In first video is of rational number, second video is operation and rational number, the third video is rational numbers as decimal. Rational number, you know, the rational number is the number which can be represented in P by Q form, where Q is not equal to 0. You know, in denominator 0 is not cannot be defined. Suppose I write 8 upon 0, this is a invalid number. This is infinite. We cannot find a value where the denominator is 0. Here the 9 upon 8 is given. You have to convert it into decimal form. How can we convert it into decimal form? I have already told you, look at the denominator. Here the denominator is 8. Convert it into 10 or power of 10. 8 cannot be converted into 10 because 8 is not a factor of 10. Then think about 100. 8 is also not a factor of 100. 8 cannot be converted into 100. Then 8 is factor of 1000. 8 can be converted into 1000 by multiplying 125. When we multiply the denominator into 125, we must multiply the numerator with 125, otherwise the value will be changed. Here this is 9 upon 8, multiply the denominator with 125. Then you also multiply the numerator with 125, otherwise the value will be changed. Then the numerator becomes 1125, then the denominator is thousands. How many zeros are in thousands? There are 3 zeros in thousands. Then we must require 3 numbers after decimals. Then this is represented as 1.125. 9 upon 8 in the decimal form is 1.125. Okay. Then here another. Suppose this is 1 upon 16. Convert this into decimal number. Think about to convert the denominator into 10 or power of 10. 16 cannot be converted into 10 because 16 is not a factor of 10. Then think about 100. 16 is not a factor of 100. Then think about 1000. 16 is also not a factor of thousands. Then it is it is a factor of 10,000. Then multiply with 625. Then when we multiply it 625, you must multiply the numerator with 625. Otherwise the value will be changed. This is 625 upon 10,000. Then how many zeros are there? There are 4 zeros. Then we must require 4 numbers after decimals. Then 625 can be converted into decimal in the form 0.0625. This is the decimal representation of 1 upon 16. Then think about the conversion of rational number into decimal by long division method. This is the method in which the denominator can be converted into 10 or power of 10. All numbers are not the factor of 10, 100, thousands. Then how can we convert it into decimal number? By long division methods. Okay, then look at here. Suppose we have given 5 upon 8. To convert it into decimal, then think about, then divide the 5 by 8. Then put 0 here, then decimal point. Then here 8 6 ja 48. 8 6 ja 48. Then next 2. Then add another 0. Then this is 8 2 ja 16. Then this is 4 0. 8 5 ja 40. Then this is 0. Then 5 upon 8 can be written as 0.625. 5 upon 8 can be written as 0.625. This is the decimal representation of 5 upon 8. Here another examples. I have already told you Only knowing the method is not sufficient, students. Please practice variety of questions which will be helpful for you. Here another question is given. Suppose convert 13 upon 5 into decimal number. How can we convert 13 upon 5 into decimal number? By long division method, divide this by 5. Then here 5 2 ja 10. 10. Then this is 3. Then how can we convert it into decimal? 3. Then here put decimal point and add 0 here. Then this is 5 6 ja 30 0. Then we get this is 2.6. 13 upon 5 converted into decimal 2.6 is the decimal form of 13 upon 5. Okay. Then next another number is given here. Suppose we have given 629 upon 125. Then convert it into decimal form. Then divide 629 into 120 upon 125. 125 5 ja is 625. Then we get 4. Then add 0. No, put decimal point. No, this cannot be divided with 125 because 40 is less than 125. Add another 0. Then here add another 0. Then 125 3 ja is 375. Then this is 25. Then add another 0. Then this is sorry. Then when you add another 0, put it 0 here. Then 125 250. 125 2 ja is equal to 250. Then here this is 250. Here this is 250 0. Then the convert 625 upon 125, which is equal to 5.032. Okay. Then 629 upon 125 converted into decimal form, which is 5.032. Okay. Then another questions. Then another. Here these are all terminating decimal number. We can convert it into decimal form. This is terminating. We can find a fixed decimal number. Think about non-terminating decimal numbers. Here suppose 1 upon 3 is given. Here 1 upon 3 is given. Convert it into decimal form. Then by using long division method, convert it into 3 1. 1 cannot be divided. Then add 0. Put it here decimals. 3 3 ja 9. Then here we get 1, then another 0. 3 3 ja 9, then put 1, another 0. This is 3 3 3. This is non-terminating repeating decimal number. We cannot get a fixed number. This can be written as 0.333 infinite form, or 1 upon 3 is equal to written as 0.3 bar. Bar means 3 is repeated infinitely. We cannot get a fixed number. Suppose 2 upon 7 is given. Convert 2 upon 7 into decimal form. Then here divide. Here use the long division method. 2 and 7. Put 0 here and put decimal point. 7 2 ja 14. Then this is 6 0. 7 8 ja 56. Then we get 4 0. 7 5 ja 35. Then 5 0. 7 7 ja 49. Then 1 0. 7 1 ja 7. We get 3. In this process, we cannot get a definite number, definite decimal number. Here 2 upon 7 converted into decimal, which is non-terminating and non-repeating decimal number. This is infinitely. Okay. Then suppose convert another questions. Take some more examples, you will be clear about it. Suppose 25 upon 12 given, convert it into decimal form. Then by using long division method, 12 2 ja 24, then we get 1. Then put decimal here, add 0. Then here by taking 1 0 we cannot get the answer because 10 is less than 12. Then put another 0 here, then put another 0. Then 12 7 ja 84, 12 80, 12 8 ja 12 8 ja 96. Then here 4 0, 12 3 ja 36. Then here 4 0, 12 3 ja 36, then another 4 0. In this process we get 3 3 3 infinitely. Then 25 upon 12 can be converted into non-terminating decimal numbers. In this process, this is 2.08333. Then this can be written as 2.083 bar, means 3 is repeated infinitely. Okay, then this is the decimal representation of 25 upon 3. This is non-terminating repeating decimal number. At first we get a terminating decimal number, then we get non-terminating repeating decimal numbers. Without long divisions, without any divisions, how can we say this is terminating? A rational number is given. Only by seeing this, how can we say this is a terminating decimal number or non-terminating decimal number? By thinking about, by taking the prime factorizations of its denominator. Suppose here, if the prime factorizations of the denominator is only the factor of 2 or 5, 2 and 5, then this gives us terminating decimal numbers, otherwise all are non-terminating decimal numbers. I will practice some examples which will clear you. Look at here. Suppose 3 upon 2. Is this a terminating decimal number or non-terminating decimal numbers? Look at the denominator. Here the denominator is 2. The 2 is the if the denominator prime factorization of the denominator is only the factor of 2 and 5, then we can say that this is terminating. Here 3 upon 2 is a terminating because the denominator is 2 here. If we convert it into decimal form, we get this is terminating. Look at here, divide. 2 1 ja 2, then 1, put decimal here, 0, 2 5 ja 10. Then we get 3 upon 2 is equal to 1.5. Yes, this is a terminating decimal number. Then take another examples. How can we say you? Only by seeing the denominator, how can we say this is either terminating or non-terminating? Suppose we have given 1 upon 15. Look at the denominator. The denominator is 15. The prime factorization of denominator is 3 into 5. This is not only the factor of 2 or 5. Here 3 is given, means 1 upon 15 is not a terminating decimal numbers. It gives us non-terminating. Suppose, look at here. Practice 1. Then we cannot solve it, put it 0. Then put decimal numbers. Here also not 10 is less than 15. Put another 0, put here 0. 15 6 ja 90. Then 10. Then 10. 15 6 ja 90. Then 10, another 0. 15 6 ja. In this way we get infinite number of 6, means 1 upon 15 is 0.0666 infinitely, which is 0.06 bar. Look at here. This is non-terminating. I have already told you, only by seeing the denominator we can say either this is terminating or non-terminating. I will solve some more examples which will clear you. Look at here. Suppose a number is given 2 upon 125. Is this a terminating or non-terminating? Factorize the denominators. The denominator 125 by prime factorization method, when we factorize, we get 5 into 5 into 5. Here the denominator factor are only 5. Yes, this is a terminating. Look at here. 125. Then put 0 here, put decimal. Then here we cannot divide because 20 is less than 125. Here put another 0. Then put 0 here. Suppose 125, 1 ja 125. Then here 75, 0. Yes, 75. Then we get, this is by dividing this, we get 6 ja 750. 125 6 ja 750. Then 2 upon 125 in the decimal form is 0.016. Here we get a terminating because the denominators factors are only 5. Then solve another examples which will give you the clarifications that if the denominator is not only the factors of 2 or 5, we cannot get a definite or terminating decimal numbers. Here take some more examples. Suppose 39 upon 20. Look at here. 39 upon 24. Is this a terminating or non-terminating? Think about the denominator. The denominator is 24. When we factorize the 24, we get 2 into 2 into 2 into 3. Then here the 24 is not only the factors of 2 or 5. Here 3 is given. Then 39 upon 24 is not a terminating decimal numbers. Let us try. Divide 39, divide by 24. Then 24 1 ja 24, 1 ja 24. Then this is 5, 1 5 15. Put the decimal here 0. Then 24 5 ja 24 6 ja 144. Divide this 6, then 0, then 26. Then 24 2 ja 48. Divide, then we get 12. Sorry, look at here. 8 2. I will try it in next page. Okay. Then here the number is given 39 upon 24. Is this a terminating or non-terminating? Look at here. The 24 is when we prime factorize, the 24 is 2 into 2 into 2 into 3. It is not only the factor of 2 or 5. Then let us try. Then 24 1 ja 24. Then we get 15. Put decimal here, put 0 here. 24 6 ja 144. Then we get 6 0. Then here 24 2 ja 48. Then we get 12 0. Here we get this is equal to here this is a twist. Look at here. Here we get 120. Yes, we get a definite terminating decimal numbers, but I have already told you, if the denominator, when we factorize the denominator, if we get only 2 or 5, this is only terminating. Otherwise this is not a terminating. When we try the long division method, at first convert it into lowest term. This is not in lowest term. This is the mistake. then divide it into 3. This is actually 13 upon 8. Then here 8 is equal to 2 into 2 into 2. Then here the 8 is the factors of only 2. Yes, this is a terminating. When any fraction is given, any rational number is given, you have to convert it into decimal. At first, look at the either this is in lowest term or not. If this is in lowest term, then you take its denominator and try either this is factors of 2 or 5 or other numbers. If only they are factors of 2 or 5, then they are terminatings, otherwise they are non-terminating. Here the questions, here another example, this is also a twist. 49 upon 14. 14, if you factorize 14, this is 2, 14 is equal to 2 into 7. This is not only the factor of 2 or 5. Then you say this is not a terminating decimal numbers, but this is terminating because this is not in lowest term. Divide it into 7 into 7. This is 7 upon 2. Here the denominator is the factor. The denominator is the multiple of only 2. Yes, this is a terminating. If we divide, we get 3.5. This is a terminating decimal numbers. Okay. Then next, express the this at first we find terminating decimal number, then we find non-terminatings and repeated. Then there are also some decimal numbers which is non-terminatings and non-repeating. These are called irrational numbers. These are not rational numbers. Then here do some operations on decimal numbers. You know the operation on the decimal numbers means additions, subtractions, multiplications and divisions. Then do some examples. Here do some examples. Operation on decimal numbers. Suppose here question is given. Here question is given. Add 15.51, 12.03 and 7.209. When we do any operation on decimal numbers, at first convert it into like decimals. Do you know what is like decimals? Like decimals means after decimals they have same numbers. If there are not same number of terms, then by putting 0, as you know, after decimal right side 0 is not, do not change the value. Then convert it into like decimals by putting 0. Suppose 15 upon 1 can be written as 15 upon 100. 12.03 can be written as 12.030. Then this is 7.209. Now these all are like decimals. You may add them. When you do any subtractions, at first also convert it into like decimals. Suppose here another examples given. Subtract 5.012 from 12.01. These are not like decimals. At first convert it into like decimals by putting 0. Then this can be written as 12.010. Then subtract 12.010 minus 5.012. Look at. Then you know this is addition, this is subtractions. Then next think about multiplications. Then when we multiply the decimal numbers, multiply it into simple multiplications. Then put the decimal. Suppose you multiply 2.4 into 3.5. Multiply into just simple as you multiply 24 into 35. Then put the decimal points. How many, by counting the how many numbers are there after decimals. Here how many numbers are after decimals? 1 and 2. Here we get the, by multiplying we get 840. 24 into 35. Then after decimals there are 1, 2, two numbers. Then put the decimals 1, 2, counting from right sides. This is 8.4. When we multiply 2.4 into 3.5, we get 8.40. This is the answer. In the same way, you can divide it by converting into like decimals. Okay. Students, please do your exercise thoroughly and ask me your doubt. I will clear your all doubts, all queries. Please ask me in my comment box. Thank you, students. In my next sessions, we will discuss about chapter 4 exponents. Till then, happy learning.